Okay, so let's see how we do for a time record on the 110-pound levitron magnetic base. So, this 1.5 inch neodymium magnets for the top, and a motor to get them spinning. And then I'm going to let it spin for a while until it stabilizes, because I get better times if it's nice and stable to start with. So I haven't started the timer. And I have a big clock because the timer is going to be hard to see on the video. So I'm still processing around. Hopefully it'll get good and stable in the middle there. Getting close. Yeah. Oh, it's pretty good. Okay, so it's floating now. So start the timer. And it's about 20 after 4. So we'll slide this off of here. You can get an idea for the height. This isn't quite the highest with this bigger magnet for the top, but there's a tissue box. Give some relative height, or the ruler to be a little more precise. So we're still a little over 6 inches, and we'll have a little extra foam in the base for the landing of this heavy magnet. In fact, I'm going to put one more piece of foam on it. So can handle the landing there. And once I'm sure it's nice and stable, I can take the cover off and show the magnets and the steel plates. They're steel plates because it mirrors the magnetic dipoles, saves almost half as many magnets as it would take if I didn't have the steel plates. And the weight's about half magnets and half steel plates. So hopefully, well, it's been getting close to 2 minutes now. It's stable enough that I can remove the top. Just don't want it to crash into the magnets. No, I do have a little tape on the magnets to try and protect things. So you can see those 12 magnets, 4 stacks of 3. Each magnet is 1 inch high, 4 inches wide, and 6 inches long. And their position is tweaked to get it a very symmetric field, because the magnets aren't quite perfect. And then lots of foam around so that in case it does wander off and hit, it doesn't hit the steel plates directly. And then there's 2 layers, there's some 1/4 inch steel plates on top, and then some 3/16 I had earlier for a smaller one underneath. So that's what the base is. It's just magnets and steel and then some foam. And I'm going to put the top back on just to protect things. Or the cover, I should say. I guess the top is the spinning part up there. And that spinning part is some 38mm diameter and 5mm thick. 2 of them, so it's a total of a centimeter thick. And the bigger magnets are hard to get stable on a smaller base, but the bigger base can handle bigger magnets. So at this point, what else? There's a lot to say. You might want to skip to the end of the video. I'm going to leave it running for the whole time. It'll hopefully be a record. Certainly be a record for not using a vacuum. There's some videos out there of putting the levitron top in the vacuum chamber. And it helps if you get the vacuum down fast enough, deep enough vacuum, because the viscous drag part, which I suspect is the dominant drag feature of this, although I'm not a fluids engineer, so I haven't been able to determine that for certain. But anyway, viscous drag doesn't drop until the air pressure gets quite low. So to have air pressure help, you have to pump it down quickly. And there's one nice video that is 9 minutes and something in the vacuum chamber. And I imagine you could do a lot longer if you could pump down the vacuum chamber fast enough. But we'll see how close we come. The closest I've heard of, or the longest I should say, in air was about 4 minutes, and we've already beat that because we're at 5 minutes now. So we'll see if we can beat the 9 minutes that is in the vacuum chamber video. That's the longest I've seen for a vacuum chamber one, at least on YouTube. I don't know if you'll be able to tell in the video. The faster the magnet's spinning, the slower the precession rate is, and so you'll actually see it, the top precessing around faster as the top slows down. So it looks a little counterintuitive, but that's when that precession rate gets down on the order of the frequency of the top spinning. That's when it'll fall. Yeah, 6 minutes and a little bit. So we're certainly past anything else I've seen for a top in air in the vacuum chamber. And this is completely undriven. There's no electromagnets, no electricity being used except for the motor to start it in the first place. So this is purely coasting. And it is slowing down because of the air drag. So it will drop at some point. You can see it's bouncing up and down a little bit. The pocket for it's a very delicate, stable region for the spinning top, but there's not much in the way of damping force, so kind of like a swing around. It kind of bounces in that pocket of stability. If it gets too non-uniform, if the field isn't symmetric, it can drift off to one side, and then it tends to slide off the field and off the whole top and land on the floor somewhere usually. When it falls, just because it gets spinning too slowly, then it tends to fall straight down. Just I have a couple pieces of foam under there that it pokes little holes in. Well, we're over 8 minutes now. Looks like it's still got a little bit of time to go. I don't want to make a lot of air currents to disturb it, but you can see that there's nothing over it holding it up. It is just spinning top levitron, much bigger base than typical, floating at 6 inches high or so, instead of the 3 inches that's more common, or some that are close to 4. Okay, well, we've hit 9 minutes. We're still floating here. Maybe we'll make 10. I don't know if you can tell in the video, it's starting to wobble just a little bit more as the speed slows down. As I mentioned, the precession rate speeds up. Of course, that makes it also increase the air drag, so it loses speed faster. But I think maybe we'll make 10 minutes. We're at 9:45 now. Yeah, so if you can see the wobbling, hopefully that's showing up in the video. Ah, we hit 10 minutes. So I think this will be a new levitron top record. Not that I've submitted anything to Guinness, but they don't have to have a monopoly on records. Okay, 10, 10:25, almost 10 and a half, plus the few seconds it took me to start the timer. Don't know if we're going to make 11. Looks like it's getting close to dropping here. And actually I've hit 11 only once in the trials, and that was a real lucky one. But maybe. We're getting close. 10 more seconds to go. And there's 11 minutes. And it's just about to drop. So watch it slam into the foam at the bottom. There. So 11 minutes and 10 seconds plus the few seconds it took me to start the timer. So as far as I know, that's a record for length of time. And you can see these are rather strong magnets, and this is just a magnet, so the minimum amount of a little nylon spindle in there to balance it.